once you're certain that the bulb is not burned out in your test light, then you're ready to actually track down a circuit. So we're going to clip the alligator clip to the negative post, and anytime you touch something that is hot, then the light will light up. So makes a quick, easy way to just go through the entire circuit and find out where you're getting voltage to. Now, in addition to that, which everybody uses the test light for that, but not everybody knows that you can also check a ground circuit. If you put the alligator clip to the positive post of the battery, now it'll light up when you have a good ground going back to the battery. So again, you want to check both sides of the circuit anytime you're troubleshooting. It's not good enough to get voltage to the device. You also have to have a complete path back to ground. And by switching the lead on the test light, you can quickly, easily check not only the hot side, but the ground side. The third tool that you'll be using, you can do exactly the same thing with a DVOM or a digital volt ohm meter that you can with the test light, but the DVOM has a few advantages. First of all, in the new computerized circuitry, you never want to use a test light or an analog digital voltmeter. The impedance is different, and the only way to safeguard your computer circuitry is to use a digital volt ohm meter. Basically, you're going to be using 90% of the time, you're either going to be using the voltage function or the ohms function. And if you're testing anything live, you want to set it on DC volts. And if you've got a range, this one's auto ranging, but if you have a range on yours, you always want to set it to something a little more than 12 volts. I think we're on AC, so we'll switch that to DC, and there we've got almost 12 volts showing on the voltage scale. You can also use when you're using voltage, you can do the same thing as the test light, and the test light's a little quicker and easier. But one thing that the volt ohm meter will do that the test light won't, you can test for continuity through a switch or through a solenoid or something like that. One caution, anytime you set it on ohms or resistance, make sure that you do not have any voltage going to the device that you're testing. You will, if it's got a fuse, you'll blow the fuse. If it's not protected, you'll blow up your whole tester. So when you're set on ohms, this one reads overload until you clip them together. Then it goes down to 0, which indicates 0 resistance. So always before you start testing something, make sure that your meter is reading correctly, and when it's not connected, you'll have an overload. When you have continuity, then it'll tell you how much resistance. Here's a basic starter solenoid, and the way these things work, you've got a coil of wire connected to this small lead and this small lead, so we should have continuity between those two. When that makes a magnetic field and closes the switch, then you will have continuity between this one and this one. But when the solenoid is not turned on, we should not have continuity between those two posts. Okay, so when he didn't have it connected, we were reading overload. When he connected here and here, it dropped back to 2 or 3 ohms of resistance, showing that winding is working. So that part of the solenoid is correct.